Hello everybody, welcome into another lesson and welcome to the final lesson of Algebra 2 Trig. So we've made it to the end of Algebra 2 Trig, and today we are going to talk about double and half angle formulas for trigonometric functions. So up here you have the double angle formulas. You have the sine of 2u equals 2 times the sine of u cosine of u. You have the cosine of 2u equals cosine squared of u minus sine squared of u. And you have the tangent of 2u equals 2 times the tangent of u over 1 minus the tangent squared of u. Then you have your half angle formulas. So the sine of u over 2 equals plus or minus the square root of 1 minus the cosine of u over 2. The cosine of u over 2 equals plus or minus the square root of 1 plus the cosine of u over 2. And then we should talk about that plus and minus. So the plus or minus depends upon which quadrant the angle u over 2 lies in. So if it lies for the sine, if the u over 2 lies in either the first or the second quadrant, you'll take the positive square root. And if it's in the third or fourth, you would take the negative square root, get a negative value for the sine. And then your cosine, if the u over 2, if it's in the first or fourth quadrant, you would take the positive square root. If it's in the second or third quadrant, you would take the negative square root. And then you have two formulas for the tangent of u over 2. It doesn't matter which one you use. Pick your poison at that point. It's either going to be 1 minus the cosine of u over the sine of u, or the sine of u over 1 plus cosine of u. It really doesn't matter which one you use. So we're going to run with these. We're going to do some examples. So let's say you were asked to find something like the tangent of 15 degrees, right? They asked you to find the tangent of 15 degrees. Well, 15 degrees is not a special angle, is it? But we can use it as a half angle formula of a special angle. That would be the same as the tangent of 30 degrees divided by 2. And in fact, why don't we draw ourselves a 30, 60, 90 right triangle? Why don't we draw that? So we'll draw a 30, 60, 90 right triangle to aid what we're doing. Alright, so for the tangent then of 30 degrees over 2, let's plug this into the formula. So this is going to be the same as, well, let's do the 1 minus cosine of u over sine of u. So this would be the same as 1 minus the cosine of 30 degrees over the sine of 30 degrees. Now, let's see here. So we have 1 minus, what is that cosine of 30? That's the square root of 3 over 2, right? So 1 minus the square root of 3 over 2 all over that sine of 30, which is 1/2. Let's simplify the numerator. You would get 2 minus the square root of 3 all over 2 all over 1/2. Well, now you have a complex fraction. You just have to invert and multiply. So this would be 2 minus the square root of 3 over 2 times 2 over 1. Well, your 2's cancel out. You should just be left with 2 minus the square root of 3. So the tangent of 15 degrees has a value exactly equal to 2 minus the square root of 3 using the formula. And if you decided to use the sine of u over 1 plus the cosine of u, you should get exactly the same result. Alright, so what if they wanted you to find the sine of 22.5 degrees? So what if you were asked to find the sine of 22.5 degrees, the exact value of that? Well, 22.5 itself is not a special angle, but it is half of a special angle. It turns out it's half of 45. So you could do this the same as the sine of 45 degrees divided by 2. And let's draw a 45, 45, 90 right triangle to aid our understanding here. So this will be a 45, 45, 90 right triangle. So 1, 1, and square root of 2. Okay. So now, what is the formula for the half angle of a sine? So this is the same as, now, are we going to use plus or minus? Well, 22.5 degrees is in the first quadrant. The sign is positive, so it'll be plus the square root. So it'll just be the regular square root of 1 minus the cosine of 45 degrees all over 2. Which then would turn into the square root of 1 minus, now what is the cosine of 45 degrees? That's the square root of 2 over 2. All that all over 2. So then we'll take the square root again. We'll simplify the numerator. That'd be 2 minus the square root of 2 all over 2 all over 2. And you have a complex fraction under the radical, so we're going to keep the radical and we're going to invert and multiply. So this would be 2 minus the square root of 2 all over 2 times 2 over 1. While your 2's cancel out, you're literally just left with the square root of the quantity of 2 minus the square root of 2. So that sine of 22.5 degrees has an exact value of the square root of 2 minus the square root of 2. Alright, now let's say we were asked to find the cosine of 67.5 degrees. So we're going to find the cosine of 67.5 degrees. Again, 67.5 itself is not a special angle, but it's half of one. It's half of 135 degrees. So this is going to be the exact same as the cosine of 135 degrees divided by 2. Well, okay. So 135 degrees divided by 2. Well, 135 is what? That's a 45 degree angle in the second quadrant. So let's draw ourselves another 45, 45, 90 right triangle. I know it's not exactly drawn to scale, but it'll do the job. So let's draw that 45, 45, 90 right triangle. And we do have a half angle formula for the cosine, so let's plug that in. Now that 67.5 itself, it's in the first quadrant, so your cosine is going to be positive. So we're going to take the positive square root. So this will be equal to the square root of 1 plus the cosine of 135 degrees, all that divided by 2. Well, this is where it gets fun now. So we're going to have 1 plus, what is the cosine of 135 degrees? So it's basically the negative cosine of 45 degrees. So this would be minus the square root of 2 over 2 all over 2. So now let's simplify the numerator under the radical. This will be 2 minus the square root of 2 all over 2 all over 2. So let's invert and multiply inside of the radical. You would end up getting 2 minus the square root of 2 all over 2 times 2 over 1. times 1/2, excuse me, because it's 2 in the denominator, so it's times 1/2. So what you should end up getting then is the square root of 2 minus the square root of 2 over 4, which should simply give you the square root of 2 minus the square root of 2, all that all over 2. That would be your cosine of 67.5 degrees. Yowzer. Yowzer. Not a fun one. And actually, I see what I did on that last one. I inverted and multiplied wrong, which can happen to anyone. So let's just do that one quickly again here. Let's cover the sine of 22.5 again. I realized the mistake I made when I went to invert and multiply. So we know the sine of 22.5 is the same as 45 degrees over 2. 22.5 lies in the first quadrant, so it'll be the positive square root of 1 minus the cosine of 45 degrees all over 2, which would equal the square root of 1 minus the square root of 2 over 2 all over 2, which would be 2 minus the square root of 2 all over 2 all over 2, which would equal 2 minus the square root of 2 over 2 times 1 over 2. So really what you should get is the square root of 2 minus the square root of 2 all over 2. So actually that's really what the sine of 22.5 degrees is. My bad, because when I didn't invert and multiply right with the fraction. So that, just watch out for mistakes like that. But the sine of 22.5 is really the square root of 2 minus the square root of 2 all over 2. That's exactly what you should get. Okay, now we can move on. So you've seen how these formulas work to find halves of special angles. So we're going to do all these in the first quadrant, where you have the cosine of u equals 3/5. It's going to be our job to find the sine of u over 2, cosine of u over 2, and the tangent of u over 2 for these triangles we've been given. So set up your right triangle. Here's angle u, here's your right triangle. Cosine was 3/5. We'll call that side B. Let's use Pythagorean theorem to find side B. So that means 5 squared equals that a squared, which is 3 squared, plus b squared. So 25 equals 9 plus b squared. B squared equals 16, so that means that b equals 4. Since we're in the first quadrant, we can keep it all positive. That'll make our lives easier. So the first thing you probably want to do is find your missing side. So we were given the cosine of u is 3/5. Why don't we use this to find the cosine of u over 2? So the cosine of u over 2, some people would tend to take this and think it's half of 3/5. That's not how it works. You have to use your special formula. And we specified that it's in the first quadrant, so you're going to do positive of the square root of 1 plus that cosine of u all over 2. So that's going to be equal to the square root of 1 plus 3/5 all over 2. which would equal the square root of 5 plus 3 all over 5 all over 2. So this is going to be the square root of 8 over 5 times 1/2. Well, this would just turn into the square root of 8 over 10. Well, we know 8 over 10 simplifies both 8 and 10 divided by 2. You would end up getting the square root of 4 divided by 5. Well, square root of 4 is a perfect square. You would get 2 over the square root of 5. But you want to rationalize the denominator, so you'll take times the square root of 5 over the square root of 5. So that means your cosine of u over 2 in this case is going to end up being 2 times the square root of 5 over 5. Now, some people would have got an answer of 3/10. That's would have been completely wrong. The cosine of u over 2 is 2 times the square root of 5 over 5. Now we'll go for the sine of u over 2. So let's find the sine of u over 2. And again, some people would think you would find the sine of u, which would give you 4/5, and then just divide it by 2. That's not how it works. You got to use your special formula. And we specified that u's in the first quadrant, which means u over 2 will also be in the first quadrant. So the sine of u over 2 is going to be the square root of 1 minus the cosine of u all over 2. So in this case, that'll be the square root of 1 minus, that cosine of u is 3/5, so 1 minus 3/5 all over 2, which would turn this into the square root of 5 minus 3 over 5 all over 2, which would then give us the square root of 2 over 5, really times 1 over 2, since you invert and multiply, since you would have a complex fraction. Well, the 2's will cancel out. You would end up with the square root of 1/5. Well, 1's a perfect square, so this would turn into 1 over the square root of 5, which you got to rationalize your denominator. So the answer you should get for the cosine, for the sine of u over 2 would end up being the square root of 5 over 5. So that would be for the sine of u over 2. You get the square root of 5 over 5. And of course, we're going to go for tangent of u over 2. So let's find the tangent of u over 2. So the tangent of u over 2, we do have a couple special formulas for. Let's use the 1 minus cosine of u over sine of u. So 1 minus the cosine of u over the sine of u, which is going to equal 1 minus, now what is your cosine of u? That's 3/5, so that'll be 1 minus 3/5 all over your sine of u, which is 4/5. So this would end up equaling 5 minus 3 over 5 all over 4 over 5, which would give you 2/5 all over 4/5. So you have a complex fraction, you just got to invert and multiply. You would end up getting 2/5 times 5 over 4. Your 5's cancel out. 2 reduces into 4. This would be 1 over 2. So the tangent of u over 2 should just give you 1/2. So you should get the tangent of u over 2 being 1/2. All right. Let's do one more for the u over 2's, then we'll go on to double angle formulas. So this time they give us that the sine of u equals 9/10. So the sine of u equals 9/10. Again, this is all going to be in the first quadrant, so your u over 2's will also be in the first quadrant. So go ahead, set up your right triangle for all this. Here's angle u, here's your right angle. Now the sine, so that's 9 over 10. So we're going to then take that 10 squared, set that equal to our a squared. Here's our a, plus our 9 squared. We want to use Pythagorean theorem to find that missing side. So that means 100 equals a squared plus 81. Well, a squared equals 19. So that means a would have to equal the square root of 19. So the missing side has a length of the square root of 19. All right. Now we know all the sides of this right triangle, we can go ahead and find these angles. We'll start with the sine of u over 2. So the sine of u over 2 would then, of course, since it's in the first quadrant, will be the positive square root. So this will be the square root of 1 minus the cosine of u all over 2. All right, so 1 minus, now what is the cosine of u? That's the square root of 19 over 10. This would all be all over 2. So this is going to be equal to the square root of 10 minus the square root of 19 all over 10 all over 2, which would just end up giving you the square root of 10 minus the square root of 19 all over 10 times 1 over 2. So this would turn into the square root of the quantity of 10 minus the square root of 19 all over 20. So yeah, we have a bit of a doozy there, don't we? So the square root of 20 at least will simplify. That's the square root of 4 times 5. So this would end up being the square root of 10 minus the square root of 19 all over 2 times the square root of 5. And this might be a case where you probably don't want to rationalize the denominator, because it's going to be hell on earth if you try to do that. Whoops, excuse me. It'll be crazy if you try to do that. So your sine of u over 2 is going to equal the square root of the quantity of 10 minus the square root of 19 all over 2 times the square root of 5. Now let's go for the cosine of u over 2. Alright, so the cosine of u over 2, so since u's in the first quadrant, your u over 2 will also be in the first quadrant, so we'll take the positive square root of, let's see, this time it'd be 1 plus the cosine of u all over 2. So this will be the square root of, let's see, 1 plus, now what is that cosine of u? That's the square root of 19 over 10. All over 2. So this would be equal to the square root of 10 plus the square root of 19 all over 10 all over 2. So this is all going to equal the square root then of 10 plus the square root of 19 all over 10 times 1 all over 2. So this would end up giving you the square root of 10 plus the square root of 19 all over the square root of 20. Well, we know at least the square root of 20 simplifies. That would be 2 times the square root of 5. So the answer you should get is 10 plus the square root of 19 all underneath the square root all over 2 times the square root of 5. And that would be your answer for the cosine of u over 2. After working out the formula, we still have to do the tangent of u over 2. Then we'll do some double angles. So let's take the tangent of u over 2. So the tangent of u over 2, let's use that 1 minus cosine of u over sine of u. So this will be 1 minus the cosine of u over the sine of u in order to find the tangent of u over 2. Well, alright, so 1 minus, now what is that cosine of u over 2? That's just going to be the square root of 19 over 10. All that divided by the sine of u, which was 9/10. So then you simplify the numerator, you would get 10 minus the square root of 19 all over 10, all that all over 9/10. Now you have a complex fraction, just invert and multiply. So you would get 10 minus the square root of 19 all over 10 times 10 over 9. Well, your 10s will cancel out, so the answer you should get for the tangent of u over 2 is 10 minus the square root of 19 all over 9. That would be the answer for the tangent of u over 2, 10 minus the square root of 19 all over 9. Alright, so those are working of the half angle formulas. Let's do some double angles. Yeah, we'll do some double angles here. You know what, I'll probably keep my triangle up here because we're going to do some very similar problems, only it's going to be for double angles as opposed to half angles. So again, everything's going to be in the first quadrant. They give us that the tangent of x equals 2. So the tangent equals 2, so that means the tangent, so that's 2 over 1. We need to find the hypotenuse, we'll call that c. Let's use our Pythagorean theorem. So c squared equals that 1 squared plus 2 squared. So that means that c squared would equal 1 plus 4, so c squared equals 5, which means that c would have to equal the square root of 5. So that means your hypotenuse equals the square root of 5. Alright, now we know the length of all sides of the triangle. So it's going to be our job to find the sine of 2u, the cosine of 2u, and the tangent of 2u. Well, let's start with the tangent of 2u since they gave us the tangent first. Why don't we call that u instead of x? But it's the same idea. Tangent of u is 2. So the tangent of 2u for the double angle formula, that of course is equal to 2 times the tangent of u all over 1 minus the tangent squared of u. Alright, so what is the tangent of u? So this will be 2 times that tangent of u. So that's just 2 all over 1 minus that tangent of u squared. So that'd be 1 minus 2 squared. which would then equal 4 over 1 minus 4, which should end up giving you 4 over negative 3, which should in fact then give you negative 4/3. So the tangent of 2u equals negative 4/3. Some would think you would just double the tangent of u and get 4. No, you would get negative 4/3. And this could jibe with the fact that u, as we said, u is in the first quadrant. It just so happened that when you doubled it, you ended up in the second quadrant. So that's how you got a negative result for 2u. So that's how you can go from positive to negative. All right. Let's find the sine of 2u. So let's see. The sine of 2u, we have a formula for a sine of a double angle. That's the same as 2 times the sine of the original angle, 2 times the sine of u times the cosine of u. So this is going to equal 2 times, what is the sine of u? That's 2 over the square root of 5, times the cosine of u, which is 1 over the square root of 5. So, let's see. Just multiply your numerators. You get 2 times 2 is 4 times 1 is 4 over 5 times the square root of 5 times the square root of 5 is just 5. So the sine of 2u would end up equaling 4/5. I think so far it's proven to be that double angle formulas seem to almost be easier to work with than half angle formulas because you don't have so many radicals. Those have been working out a little bit nicer. Alright, so last but not least, let's find the cosine of 2u. So the cosine of a double angle is the same as the cosine squared of the original angle, cosine squared of u minus the sine squared of u. Which, what is the cosine of u? Well, that's 2 over the square root of 5, so that, that's 1 over the square root of 5 for the cosine. So that's 1 over the square root of 5, but we have to square that quantity since it's the cosine squared, minus what is going to be your sine. That's 2 over the square root of 5, but we have to square that quantity since it's sine squared. So this would simplify into 1 over 5 minus 4 over 5, which should give you a cosine of negative 3/5. So the cosine of 2u in this case would end up being negative 3/5. And I got one more problem like this, then we're going to solve some trig equations that involve the double angle formulas and the half angle formulas. Alright, what do we have here? So we have the cosine of x equal x. I don't want to use x. Cosine of u equals 1/3. So we got the cosine of u equals 1/3. So 1/3 for the cosine. Let's find side b. So that means 3 squared would equal that 1 squared plus b squared, which then means that 9 equals 1 plus b squared. So b squared equals 8, which then means that b, since we're in the first quadrant, will be positive. That's the square root of 8, which is 2 times the square root of 2. So b will have a length of 2 times the square root of 2. Alright, so we found the missing side. Now we can proceed to find any of these 2u's, let's start with the cosine of 2u, since they give us the cosine of u. So the cosine of 2u, that equals, of course, the cosine squared of u minus the sine squared of u, which would equal, what is the cosine of u? That's just 1/3, but that would be 1/3 squared minus your sine squared of u, so that would be 2 times the square root of 2 all over 3 squared. Well, what is 1/3 to the second power? That's 1/9 minus, now, what is 2 times the square root of 2 to the second power? So that'd be 4 times 2, that'd be 8, so that'd be minus 8/9. So that means the cosine of 2u should equal negative 7/9. So in this case, the cosine of 2u would equal negative 7/9. And we'll go next for the sine of 2u. So the sine of 2u is going to then equal 2 times the sine of u times the cosine of u. So this would be 2 times, now what is the sine of u? That's 2 times the square root of 2 over 3 times the cosine of u, which is 1/3. So when you simplify this, you should get the sine of 2u is 4 times the square root of 2 all over 9. So the sine of 2u equals 4 times the square root of 2 over 9. And then last but not least, let's find the tangent of 2u. All right, the tangent of 2u. So the tangent of a double angle is the same as 2 times the tangent of the single angle divided by 1 minus the tangent of the angle squared. So 1 minus the tangent squared of u. So in the numerator, you'll take 2 times the value of the tangent of u, which in this case would just be 2 times the square root of 2, all over 1 minus that quantity of 2 times the square root of 2 squared. So this would end up being 4 times the square root of 2 all over 1 minus 8, which should just end up giving you negative 4 times the square root of 2 all over 7. So the tangent of 2u would equal negative 4 times the square root of 2 over 7. Alright, so those are your double angle examples. Now let's solve some equations here. Alright, so we're going to do general form of some of these equations. Let's say you have something like the cosine of 2x equals negative 1. You want to find the value of x. Well, there's a couple of options here. You can definitely use your double angle formula and solve it that way, but you're going to be introducing sine into it, and then you're going to have to turn around and either pick whether you want to work with sine or cosine and then use the Pythagorean identity to convert one of them into the other. Or there's another trick if you have a simple double angle equation like this. What is the cosine inverse of negative 1? If you take the cosine inverse of both sides, what gives you a cosine of negative 1? Well, that's going to be pi, right? That would be pi. So that would mean 2x is going to equal pi, but in general form, so this would be pi plus 2n pi. So you would get pi plus 2n pi. We just want to find the answer for x. Well, you're just going to divide everything by 2. So x would equal pi over 2 plus n pi. And I guarantee you, if you put pi over 2 for n being 0, you would get the cosine of pi equals -1. And if you put in 1 for the pi, you would get the cosine of 3 pi over 2 times 2, which would give you the cosine of 3 pi. That would equal -1. So the general solution in this case would be x equals pi over 2 plus n pi. So sometimes it's not always convenient to convert to the double angle formula. Now there are times it is, and we're going to have some equations like that here, but yes, like this one coming up. Let's say you have the sine of 2x plus the sine of x equals 0. So you have the sine of 2x plus the sine of x equals 0. Well, you don't have a nice clean-cut double angle equal to a number. Unfortunately, that trick just doesn't work this time. So we're going to have to convert that sine of 2x into the double angle formula. So this would be the same as 2 times the sine of x cosine of x plus the sine of x is equal to 0. Well, notice we can factor out a sine of x, so that's nice. So you'll have sine of x times the quantity of 2 cosine of x plus 1 equals 0. So of course just set each of these factors equal to 0, so sine of x equals 0. Now when is the sine 0? In the interval from 0 to 2 pi non-inclusive. Well, when x is 0 or pi, right? In fact, if you put in 0 or pi into the original equation, you'll see that you would get 0 equals 0. So both of these work. Both of these check out. But what about for 2 times the cosine of x plus 1 equals 0? This is where it could get interesting. So 2 times the cosine of x would equal -1. That means the cosine of x would equal -1/2. Well, let's set up a 30, 60, 90 right triangle. That's where you could get cosine values of the -1/2. So let's set up the 30. Here's 30. Here's 60. There's the 90. Okay, so 1, square root of 3, and 2. All right. When do you get a cosine of -1/2 in the interval from 0 to 2 pi? Well, the cosine is negative in both the second and third quadrants. A cosine of a 60-degree angle gives you 1/2, so that would have to mean 120, which is 2 pi over 3, and then again at 240, which is 4 pi over 3, so you should end up getting x would equal then 2 pi over 3 and 4 pi over 3 for those solutions. But we do have to test these two for an extraneous solution. So this is where it's going to get fun. We need to put these into the original equation. If you put 2 pi over 3 in for sine of 2x, you would end up getting the sine of 4 pi over 3 plus the sine of pi over 3, I'm sorry, of 2 pi over 3 equal to 0. Well, 4 pi over 3 is in the third quadrant. We know that's negative. So you would end up getting negative of the square root of 3 over 2 And then you would end up having, of course, negative square root of 3 over 2, and then 2 pi over 3 is in the second quadrant, so that'd be plus the square root of 3 over 2 equal to 0. Well, they sure do. They sure do equal 0, so we know 2 pi over 3 is going to work. Now, what about if we put in 4 pi over 3? So what is 2 times 4 pi over 3? That's 8 pi over 3. And then you'd have the, so sine of 8 pi over 3 plus the sine of 4 pi over 3. Well, the sine of 8 pi over 3, that's definitely past 2 pi, so if you subtract 2 pi, this would turn into the sine of 2 pi over 3 plus the sine of 4 pi over 3 which would give you a positive square root of 3 over 2 minus the square root of 3 over 2, which would give you 0. So we know 4 pi over 3 actually works also. So there's that. Now we got to write our solutions. So we know 0 and pi work. So honestly, we can just go for our solutions. For the general form, we can say x equals 0 plus n pi, because every single pi you get a sine of 0. So 0 plus n pi would just simply be n pi. That accounts for both 0 and pi of our solution sets. Now, what else? You're also going to get 2 pi over 3 plus 2n pi, because the sine is periodic for 2 pi. You also get 4 pi over 3 plus 2n pi. So your three solutions in general form for this trig equation are going to be n pi, 2 pi over 3 plus 2n pi, and 4 pi over 3 plus 2n pi. And I have 4 more. All right. So let's see. We have the cosine of 2x minus the cosine of x is equal to 0. So you have the cosine of 2x minus the cosine of x equals 0. Well, this is where you probably want to use your double angle formula. So this would turn into the cosine squared of x minus the sine squared of x minus the cosine of x is equal to 0. Well, it would be nice if we could get rid of that sine squared and turn it into cosine squared, right? In fact, we can, because 1 minus cosine squared is sine squared. So this would turn into cosine squared of x minus the quantity of 1 minus cosine squared of x minus cosine of x is equal to 0. So this would be cosine squared of x minus 1 plus cosine squared of x minus the cosine of x equals 0. So this would become 2 cosine squared of x minus cosine of x minus 1 equals 0. So now we just have a nice quadratic trig equation to work with. So let's factor this. Of course, you'll have cosine of x in some version of 1, and then you'll have 2 cosine of x in some version of 1 equal to 0. So let's see, 2 cosine squared of x plus cosine of x minus 2 cosine of x gives you a negative cosine of x minus 1. All right, so this should factor into the quantity of cosine of x minus 1 times the quantity of 2 cosine of x plus 1 is equal to 0. All right, so now we just set each of these factors equal to 0, so we have the cosine of x equals 1. Where from 0 to 2 pi does the cosine of x equal 1? Well, it's just going to be 0, right? X would equal 0. And if we put in cosine of 2 times 0, that's cosine of 0, which is 1 minus 1 equals 0. So that one definitely checks out. Now how about 2 cosine of x plus 1 equal to 0? So that would be 2 times the cosine of x equals negative 1. So that means the cosine of x would have to equal negative 1/2. So let's draw another 30, 60, 90 right triangle. So 30, 60, and 90. All right, so let's see. This is 1. This is square root of 3. This is 2. All right. So again, the cosine is always going to be negative in the second and third quadrants. Now, cosine being 1/2 is based on a 60-degree angle, so that would have to mean 2 pi over 3 and 4 pi over 3 would be your answers for x in the interval from 0 to 2 pi. But we need to check the 2 pi over 3 and the 4 pi over 3 for extraneous solutions. So let's go ahead and do that real quick. We got to rule that out, any extraneous solutions. So let's deal with 2 pi over 3 first. So 2 pi over 3 times 2, that would be the cosine of 4 pi over 3, minus then the cosine of 2 pi over 3. Let's see if that equals 0. Well, all right, what is the cosine of 4 pi over 3? Well, that's just going to end up being negative 1/2, right? You end up getting negative 1/2 minus, what is the cosine of 2 pi over 3? That's also negative 1/2. Well, that would end up giving you negative 1/2 plus 1/2 equals 0, which we know to be true. So 2 pi over 3 is definitely going to check out. Now we need to test 4 pi over 3. All right, so if we put in 4 pi over 3 in the original equation, 2 times 4 pi over 3, you would get the cosine of 8 pi over 3 minus the cosine of 4 pi over 3. Well, 8 pi over 3 is past 2 pi, so if you subtract 2 pi from that, you end up getting the cosine of 2 pi over 3. Then this would be minus the cosine of 4 pi over 3. Which we happen to know that the cosine of 2 pi over 3 is negative 1/2 minus the cosine of 4 pi over 3 is negative 1/2. You end up with the same scenario where 4 pi over 3 also works. So we have 3 general solutions to this equation, and we'll list them. So we can do for the general solution, we know, again, cosine is periodic at 2 pi. So 0 plus 2n pi, that would just simplify into 2n pi. That's one general solution. And then you would have 2 pi over 3 plus 2n pi. And then you'd also have 4 pi over 3 plus 2n pi. So those would be your three general solutions to this particular trig equation. All right, I got three more. Got some half-angle problems. Alright, so we have the cosine of x all over 2 minus the sine of x equals 0. That looks pretty hideous, doesn't it? Because we know what the cosine of u over 2 is. Well, first things first, I would highly suggest we get the sine of x by itself. Let's get each term by itself. So this would be the cosine of x all over 2 equals the sine of x. There's a reason for this. Now, what is the cosine of x over 2? That would be the square root of 1 plus the cosine of x all over 2 would equal the sine of x. All right. And it doesn't matter in this case if we take positive or negative of the square root, because what we need to do is get rid of the radical. We need to square both sides. So if we do that, you'll end up getting 1 plus cosine of x all over 2 is equal to sine squared of x. Which now, what you're going to have is 2 sine squared of x equals 1 plus the cosine of x. Well, we should probably convert that sine squared of x into a cosine. So we know sine squared of x, that equals 1 minus cosine squared of x. So we'll take 2 times 1 minus the cosine squared of x. Set that equal to 1 plus the cosine of x. So you'll get 2 minus 2 cosine squared of x equals 1 plus cosine of x, which would simplify then into 2 cosine squared of x plus cosine of x minus 1 equals 0. Now we have a nice quadratic trig equation to work with. So this would factor, of course, into a form of cosine of x and 1. And then we'll have the form of 2 cosine of x and a 1. But which one is minus 1? Which one's plus 1? So multiply these by foiling. 2 cosine squared of x minus cosine of x plus 2 cosine of x gives you the positive middle term of cosine of x, then minus 1. So this will factor into cosine of x plus 1 times the quantity of 2 cosine of x minus 1. I'm going to erase everything here below the original equation so we don't run out of room. Alright, so if you set the cosine of x plus 1 equal to 0, you get cosine of x equals negative 1. Where in the interval from 0 to 2 pi do you get a cosine of negative 1? You get it when x equals pi, right? So x would equal pi. And let's test it right now. So the cosine of pi over 2 is definitely 0, minus the sine of pi is 0. So 0 minus 0 is 0. We know pi is going to work as a solution, but what about 2 times the cosine of x minus 1. So this would become 2 cosine of x equals 1, which would then have to mean that the cosine of x equals 1/2. So when is the cosine positive 1/2? Well, the cosine's only positive in the first and fourth quadrants, and it's based off of a 60-degree angle. So x would have to then only equal pi over 3 and 5 pi over 3 in that interval. However, we're not done yet. We need to test for extraneous solutions. So what is the cosine of pi over 3 divided by 2? Well, that actually turns into the cosine of pi over 6, then minus the sine of pi over 3. Set that equal to 0. Okay, so what is the cosine of pi over 6? That's the square root of 3 over 2 minus, what's the sine of pi over 3? That's also the square root of 3 over 2. Set that equal to 0. Well, left side equals 0. You have a true statement for pi over 3. Now, this is where it could get interesting. What about 5 pi over 3? Alright, so 5 pi over 3 divided by 2 would give you the cosine of 5 pi over 6, which would definitely be in the second quadrant. So cosine of 5 pi over 6 minus the sine of 5 pi over 3, which is in the fourth quadrant, set that equal to 0. Cosine of 5 pi over 6 is based off of a 30-degree angle in the second quadrant, so that would be negative square root of 3 over 2 minus, now what is the sine of 5 pi over 3? That's like a 60-degree angle in the fourth quadrant. That would be the negative of the square root of 3 over 2 equal to 0. So you would end up getting negative of the square root of 3 over 2 plus the square root of 3 over 2 equal to 0. And we know that's a true statement, so 5 pi over 3 also works. So once again, we have 3 general solutions. So to write those, for the pi, it's going to be x equals pi plus 2n pi. And then you'll end up having pi over 3 plus 2n pi. Then you'll end up having 5 pi over 3 plus 2n pi. So that would be the 3 general solutions to this trig equation. X equals pi plus 2n pi, pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. And I got just 2 more. Actually, I think we'll just do 1. What if we had, this time, the sine of x all over 2 plus the cosine of x equal to 0. So we have the sine of x all over 2 plus the cosine of x equal to 0. Once again, I'm going to highly suggest that we get each of these terms by themselves on different sides. So this would end up turning into the sine of x all over 2 equals the negative cosine of x. because when you use a double angle formula, you're going to have a square root, and you're going to have to square both sides. So the sine of x over 2, it's either plus or minus the square root of 1 minus cosine of x over 2, but since we're going to square both sides, it doesn't matter which square root we use, whether it's positive or negative. So we'll just say the square root of 1 minus the cosine of x all over 2 equals negative of the cosine of x. Now we can square both sides. You get 1 minus the cosine of x all over 2 equals cosine squared of x. So then you would have 1 minus the cosine of x equals 2 cosine squared of x. And this would simplify into 2 cosine squared of x plus the cosine of x minus 1 equals 0. And now you just have a nice quadratic trig equation. So you can factor this into a form of cosine of x and 1 and 2 cosine of x and 1. Alright, so let's see, 2 cosine squared of x minus cosine of x plus 2 cosine of x gives you a positive middle term, minus 1. Alright, so you have the cosine of x plus 1 times the quantity of 2 cosine of x minus 1. So set each of your terms equal to 0. So cosine of x would equal negative 1. Well, in the interval from 0 to 2 pi, cosine is only negative 1 at pi. So x equals pi. And let's test that one right away. If I take the sine of pi over 2, that's positive 1 plus the cosine of pi, which is negative 1. Well, 1 minus 1 is 0. So we can verify that pi is going to work. Now this is where it could get interesting. So we have 2 times the cosine of x would equal 1, which means the cosine of x would equal 1/2. Now when is the cosine positive 1/2? It's going to be based on a 60-degree angle in the first and fourth quadrant. So that would end up being when x is pi over 3, and then once again at 5 pi over 3. Now the only thing left to do is verify extraneous solutions. See if it would work with the original. Alright, so what is the sine of pi over 3 over 2? That's the same as the sine of pi over 6, right? So the sine of pi over 6 plus the cosine of pi over 3, does that equal 0? Well, okay, so what is the sine of pi over 6? That's going to then end up being, so that's a sine of 30, that's going to be 1/2, plus what is the cosine of pi over 3? That's the cosine of 60, that's actually another 1/2. That's like saying 1/2 plus 1/2 equals 0, which would give you 1 equals 0. We know that's not true, so pi over 3 is an extraneous solution. That one's not going to work. So then what we have to do now is we need to see about 5 pi over 3. So what is the sine of 5 pi over 3 divided by 2? That's the same as the sine of 5 pi over 6, which would give you a positive sign because it's in the second quadrant. Then you have plus the cosine of 5 pi over 3. Set all those equal to 0. What's the sine of 5 pi over 6? So that's the sine of a 30-degree angle in the second quadrant. That would give you positive 1/2 plus what is the cosine of 5 pi over 3. So that's the cosine of a 60-degree angle in the second quadrant. That's another 1/2. So that's like saying 1/2 plus 1/2 equals 0. That's like saying 1 equals 0. Again, that's just not true. So 5 pi over 3 is also an extraneous solution. So we only have one verifiable solution to this equation, and that's pi. But if you want to write it in the notation for, if you want to write it out for the general solution, that would just be x equals pi plus 2n pi. And that would be the best we could get. There's only one general solution, x equals pi plus 2n pi. This is why we have to verify all of our solutions for extraneous solutions. So sorry about this long-winded lesson, but this is it for Algebra 2 Trig. So thank you everybody who stuck with me so far. Look for that Welcome to Pre-Calculus video next, because after this lesson we are officially into pre-calculus now. So I'll go into what to expect in pre-calculus, which is the last hurrah before Calculus 1. So I hope everyone has a great day. Take care.